सर आपकी आवाज नहीं आ रही।
Audible. Sorry, I'm not audible, but I think now I am here. So let me give you again uh, back through of this thing. So I was just telling you that you people must have to make an environment which name as dock. If you remember that how we made the Conda environments, here you have made the here I have made the Conda environment by using same command like Conda activate, Conda create dash n and dock means the same command which we were using, and then I have activated this dock environment actually. So till here, you have to just go through your knowledge which you have accumulated. And then here in my lead folder, I have made a folder which name as doc. Then I have made a folder which name as Vina. Vina requires already prepared PDBQT files. So the PDBQT files which we got from, let me share the whole screen actually, because I will be moving between different windows. So here is my actually this Autodoc tool. So the files which you have prepared from Autodoc tools, you can use them for the Vina thing. And then Vina, you can see that this is very quick program. Vina files I have already prepared because sometimes it take a few moments. So let me check what's in my folder actually. I have prepared a whole tutorial for you people. I will send you. Here is a file 1hrv.pdb, which we were using in our last session in the PyMol, if you remember. Let me open the PyMol here. It's somewhere here. Okay, it will open. So in the PyMol, we were using a file. We were fetching a file. Let me fetch fetch1hrv. I will press enter. And here you can see a file has been opened. So this is the same file which we are manipulating, and we will use it in this our environment. And from that file in this Autodoc tools, I have prepared receptor.pdbq. And then the ligand which we are going to use is its native ligand actually. The ligand which is already bound to this protein. Okay, you can use any ligand actually, and I'm gonna use this particular ligand because I wanna see that which particular position it is attached, just for the purpose of tutorial actually. We can use any of these things. And then I have named it as a ligand.pdbqt receptor. I have named as the receptor.pdbqt. One thing which is important is to create a file by yourself is called config.txt. Let me open it in code actually, as we were opening last time the things. So in code, you can open anything. Here you can see you can change this file actually. So this is Vina configuration file. So this is example which we were doing. So you can delete it, you can leave it as such. So receptor is my receptor.pdbqt, ligand is my ligand.pdbqt. This thing matters. The binding site center, the X, Y, and Z position. That what is the X position, what is the Y position, and what is the Z position, and what is the grid size box. That this is either 22, 22, 22. Let me show you that this thing is important, that how we take this position. The many people who are already doing the docking and other things, they doesn't know that how we can get these things. This is very easy, that in the PyMol in which we can see this native ligand is bound and we can see this is the active site. I will just select the ligand, and here in this command box, let me just make it big, small actually. There are a lot of resolution issues in Windows actually. I will just select it. I will type get underscore position. I will press enter. And here you can see this is the position of ligands. 24, 26, and 125.53. I will copy that position and I will paste these things here. So this is my first position. This is not 124, this is 24. So, and this is my second position. Remember, if there is just only one comma addition is there, then you will get an error. So be careful while copying and pasting the things that you wouldn't add anything extra here. Otherwise, it will give you error. And then you will save it. So this is how you get a position of the active site. You will just type a command, get underscore position, and then you will get the position into the X, Y, and Z. And then here we got the box size. The box size, we can use the maximum one. For example, I will say it 120, 120, 120, until and unless we know the exact grid box size from the Autodock tool. If you remember in Autodock tool, we can get this grid box size actually from here. We can select the things and then we can create the grid box that what are the in XYZ dimension and what is actually the XYZ center. So these are the centers and these are the number of the points. Here we have written down the center, and even if you are doing the Autodock 4.2 docking and you are creating grid box, you can get the position and then you can write them down here. But because Autodock also do that, I mean, you are selecting whole ligand, therefore I didn't tell you at that particular time. So here you need to be very careful by writing these kind of things, the X, Y, Z centers, and then the grid box size in dimension. Exhaustiveness means how many search it should make. So by default, it is 10. If you want to change it, you can write it down. The number of modes, the energy ranges from means lower than 4 will not come there. Okay. And these are the two commands which I just put them, these hashes there. So these are just to memorize them, what command you want to run. Then I will say Control S, I will save it, and then I will come back here. So I need receptor file, I need ligand files, both in PDB QT. So let me check. If you want to check specific files, PDB QT, you can check them like this. And let's check that PDB QT, and you can see here, we got here ligand PDB QT, out.pdb QT, and receptor. Because I have checked it, I will remove out.pdb QT file. And then here you can see we will here with two these files, ligands and receptors. So we have these files here actually in this folder. Okay, and okay, one thing was left at how we can install the Autodock Vina. So very simple. You need to write down this command, which is I think you people must have memorized. Let me just put it in the clear thing. Sudo apt get update. So I will enter. So I need to give it my password, and then it will just update the things automatically. And then our next command that is like this, sudo apt install Autodock Vina. I will send you these commands anyway. And then you will press enter because Autodock Vina is already installed here. So it is just telling me that it's already installed. And then if you want to check that if your Vina is installed or not, you will write down Vina help and then it will open a help file. So this is an indication that Vina has been opened. Okay. Here it should be 2 hashes, I think. So I will send you this file. This is like this. Okay. And then that one is appropriate actually. Okay, so you know to be very careful while these things, these 2 hashes actually, that how it's open the help file. It's just telling you what should be the input file, such spaces, because we have already a config file in which all these things are present. So we don't need these arguments actually. We just need to run Autodoc very easily. So in config file, if you remember, which I have opened with the code here, I have put a command to run the Autodoc Vina actually, that you will select Vina. So this is a command to run it in Windows while using the Autodoc tools. And this is a command to use it in Linux. I have put these two. I'm copying that command. I am pasting it here. Okay. Here we don't need log for this time. So Vina, we got configuration file whose name is config.txt. Then there will be out file, which is named as out.pdbqt. And then I will press enter. And now it's just started. It has started Autodoc Vina, this version. Okay. And then it's saying you that, okay, if you use Autodoc Vina, I think I have given it 120 points. So it will take some time to process Autodoc file. So it's searching the grid file. Searching is done. And then it will just, okay. Sometimes it's give me a warning. I have not given it CPU. Okay. But we don't need to give it CPU. It will take all the CPUs if I haven't given it anything. So if it will give us warning here, if we have selected it, the more space than the protein. So it will just give me a warning that the space volume is greater than these angstrom. So you need to be very careful. And this is the particularly the thing that Autodoc Vina is docking. So Autodoc tool, I think you may have experienced sometimes for a shorter version, it's very quick. But when you when you run the evaluations which are longer, it may take more than 1 hour to run. But here you can say in Vina, it's very quick. It's just at 20, 25, and 30%, and it will reach to 100% very quickly. And after going to the 100%, then what it will do, it will give you a file which is called out.pdb. And those out.pdb files, they can be analyzed by either by Autodoc tools or by UCSF Chimera. Chimera, I think last time we have run that, and I have shown you that in the tools and view doc, you can see the things that how the ligand molecules that is bound to the different parts of the protein. And even ADT, you can also check that which particular poses are formed by the Autodoc Vina. So these are the few things, and even let's come and let's see the results, that how the results will be given from Autodoc Vina. So because here I have given it exhaustiveness, if you want it very quick, just remove this. If you want it very exhaustiveness, means you can also increase this value. You can also add here random seeds, that how many random poses, random structures it creates, and then it checks for the docked poses. So it's about to finish. I think it's about 90%. And after 90%, it will give me a table. And in that table, if our docking is successful, it will give me energy values. So energy values, they also depend that how we have selected our config file. So let me go to the config file here. We have made our config file like this. If there is any error, if the centers are not good, if the grid box is not good, then we will get nothing in you can see in the table file. And therefore, I will suggest another program to download and install in your laptops actually. So let's see here the results. I think results have come. So the first mode, that energy is about minus 7.07. And then here you can see the energy like this. I think last time we had analyzed the DLG file And you can also see a table here in which you can get the energy values and RMST values. Maybe many of you have seen that table in a DLG file. Otherwise, I will show you in the end that how you can utilize this table in the DLG file. So this is our first pose, and this is the second one. And second one is very distinct, very different from the first one. So we are getting different poses from each other. So we got here top 10 poses. You can also ask it to give more than 10 poses, but 10 are enough because we just want this top one. And if we look at here, ls dash, and then we can say ltr, here you can see that it has given me a file which is called out.pdbqt. Let's see what's inside it. Code out.pdbqt. And in VS Code here, you can see these are the Autodoc results. This is the model one. This is energy score. And these are the interaction scores, bound, unbound. And this is actually the ligand, which is present here. And then here's the second model. Second model energy score is this one. And then this is the dimension of that particular ligand. So this is how you can do the docking with the Vina, and Vina is very quick in comparison with Autodoc 4. And therefore, this is ideal program for screening of thousands of, you can see the ligand molecule. So if I give you a file of the 1,000 ligands and I ask you that why not you virtually screen it, and it's very difficult on Autodoc 4.2 that one by one you need to do it. It may take you 1,000 hours. But on Autodoc Vina, you just start it. In the next session, we will do visual screening actually the next week. And then you will see that if there is a file of 100 ligands, those can be screened automatically against one target. And it will take one, another. But now there is a challenge. One challenge I'm giving you people is that, so you got here the out file from the Vina, and now you need to analyze it. You need to convert it into the poses like the poses of Autodoc 4.2. So I want you people, you can use the same file, same PDBQT files, install Autodoc Vina on your Linux systems which are present in the Windows, and then run it. Run it with this config file. I will send you this config file shortly. You can also make your own config file. And another program which I was referring to, that if you wanna go into some advanced form and then you wanna go towards the docking thing, let me at least tell you the program which I'm referring. So this is the program which is called ADFR. ADFR program, it provides you about the docking site. It identifies the cavities, the active sites for you people. So I had downloaded that for you people somewhere here, this one. So this is a tool which you need to download, and then you need to install it in your machine. And then after that, when you will install it, so it's asking me, you want to install it? I said, yes, I want to install it. And then it will ask me that where I want to install and where I shouldn't want. So let me close because I have opened many windows actually to show you. Let me just close the things. So I'm here with the terminal thing. So you just need to install this program, and then you need to check it, this program, that how particularly it's working on. So ADRF actually, it comes in form of either the AD. Did I install it or not? Oh no, I think I just asked it to install, but it's not installed yet. So it's just saying me, okay, I'll say it next. So it will be installed in the program file 86. So it's just installing that. And after installing, it will just open a file which may need Java. I am not sure, but it may need Java. So I will ask it to create a desktop icon. So it's just finished. Let's see that either it has given me an icon or not. So this is the icon of AGRF. So it comes with ADRF, but its name here is AGRF. So this is the program. It may take some time, and it will check the dependent repositories. So it's very much easier once it's open for the first time, then it will keeps on opening. So the first time is an issue because it's compiling different things. It's just starting certain servers on your local PC. So in the first time, it will just identify the libraries and graphics, then everything will be okay. So it's saying that I got 8 CPUs here. It's connecting to that. So it's just asking me that I should open the receptor PDB Qt files. So I think I have saved my PDB Qt files somewhere. I think I have put them into the doc file. So why not I copy them from there? I have told you one shortcut that if you want to open the Windows Explorer, then you will type explorer.exe and then dot, and then it will automatically opens the folder in which your files will be present. Okay, so this is our ligand, this is our receptor. I'm gonna copy them and I'm gonna paste them here in form of test on the desktop, because it will be difficult to go to the file. So in the test, I have opened the receptors, then ligand, I have opened the ligand molecules. So here you can see that we got a box actually. We got the ligand molecule and we got the box here. And then what we can do, we can prepare the docking box, or we will be able, so here are different options which are present here, that you can make the box here. Let me just put it here. So you got different options. When you just put it on the option, it will say that center on docking box, okay, and then center on receptor molecules or show receptor, hide receptors. This is about the surface thing, and this is about the grid. If you want to make a grid specifically around a certain amino acids, then you need to select them, that your ligand molecule is interacting with these particular, but we just want it open. We don't want it that we just make the active sites, which is just, you can say that not specific actually. So we are not making a very specific site. We don't need any flexible residue. Otherwise, we can select them. We can select them from here. We can select them from here. So here I will say compute pockets. When I will say compute pockets, it will detect all the pockets which are actually present in this receptor, if there are any. So of course there should be, because we got the ligand, and here you can see that it has computed these pockets. If I will select them all, then you can see there are a lot of pockets here. So I will deselect them. I will select one, I will select two. So these are the potential active sites which are present in my receptor. So normally you don't need them, but this is for the advanced people who just wanna do the docking in a very efficient way. And then if you just do that, you will get these active site docking. So these are your docking things. And then what you can do, you can generate a target file. So this target file, it will contain all the details of these active sites. That these are the active sites, and it requires all these kind of details. So it will generate this. it will make a box. And then afterwards, I will click on this hand thing. It will give me all these informations. Here you can see very precise information about XYZ centers and the size of the box. If you remember, randomly we have put the size 120, 120, 120. Okay. And here we put 39 point something, 26 and 125. But it has given us very precise these things. If I just want to make a box around these particular amino acids, even I can make that, and it will change all these box parameters accordingly. And here is the spacing thing, and here is the smoothing thing, but we just need these 7 things. And we will copy and paste these all 7 things into our code file, which we were here, code and config.txt. That if you remember that we had the config file like this, 24, 26, or 125, and 120, 120, 120. If we make it very precise on these bases, means 75, 87, 70, it will save our time. Because when you are doing the 1,000 ligands actually, and then if you just save 20, 30 seconds, it will be a lot of time actually. So use this ligand when you are gonna make use of the virtual screening, and you are gonna use the things which are a bit complicated, or you are just gonna do, you can say that again a particular amino acid, like I wanna say that I want box only these amino acids. Here you can see a particular box has been created.